We have one question from the chapter quadrilateral that is based on converse of midpoint theorem. So let's first read the question. It says that P is a point. P is the midpoint of side CD. P is the midpoint of side CD of a parallelogram. As you can see, ABCD is given a parallelogram. Now, what does it say further? It says a line through C. Line through C is drawn and it is drawn parallel to AP. So we are given this line being parallel to this. And it says that this line drawn, which is parallel to PA, intersect when DA is produced to point R. What we have to prove in the first part is to prove DA is equal to AR. That means we need to prove this length DA is equal to AR. Well, as I said, this question is based on the property of converse of midpoint theorem. So let's just brief it. What is converse of midpoint theorem says that? It says that if a line is drawn through the midpoint of one side, and if it is drawn parallel to the other side, then it will bisect the third side. That means result will be, say, AP is equal to BC. Now let's begin with applying this property. So I'm going to consider this triangle, as it is very clear that what we have to prove here. This gives an idea that we need to apply converse of midpoint theorem in this triangle. Now look into this triangle. What do we know here? We know that P is the midpoint of one side, right? P is the midpoint of this side of the triangle, and PA, as you can see, is drawn parallel to CR. That's what given here. So by converse of midpoint, I can say that A will be the midpoint of the third side, right? So that means A will be the midpoint of third side, implies DA is equal to AR. So let's write down the proof part. So we'll be saying in triangle, this is triangle DCR, we have P as the midpoint, right? P is the midpoint of P is the midpoint of DC, and PA is parallel to CR. So therefore we can say that A is the midpoint. A is the midpoint of DR. Therefore we can say that AD is equal to AR. And you must have to write down this theorem here, or you may simply write converse of midpoint. That's how we prove the first part. Now let's check the second part. What do we have to prove in the next part? Is to prove CQ is equal to CQ. As you can see, this is CQ is equal to QR. So here too we can apply the midpoint theorem. Now look into this. We know that we have proved A as the midpoint of one side, A as the midpoint of this side. And we know that this is parallel, right? This is parallel to this because opposite sides of parallelogram are equal. So by applying once again the converse of midpoint, we can say that Q will be the midpoint of this. So let me shed the triangle that will give you more clarity. So if I consider this triangle, this is triangle. Once again, we are considering the same triangle here. Now check here. So we will write down, so that is in triangle, that same triangle DCR. A is the midpoint, right? A is the midpoint. A is the midpoint of DR, and that's proved above, right? From here, right? And AQ is parallel to DC. Now, why this is parallel? Because it's given a parallelogram, right? This is given a parallelogram, and parts of parallel line are parallel. So I can say this being parallel to this, right? These two can be set parallel. So we'll say that reason is there. Therefore, we can say that Q is the midpoint. Q is the midpoint of CR. So this means that if this is the midpoint, I can say these two are equal. That means we can say that CQ is equal to QR. That's what we need to prove in this question. I'll come with the next question now.